All right, today we're gonna look at rational versus irrational numbers. So that's classifying real numbers and real number expressions. Learning goals and key terms. Learning goals, understanding the subsets of the real numbers, classifying real numbers as rational or irrational. Then key terms, you got your natural numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers, square roots, perfect squares, repeating decimals, and terminating decimals. Alright, so introducing the real number system. All numbers can be represented on a number line, are called real numbers, and they can be classified according to their characteristics. Alright, so you got two sets of real numbers. You got rational numbers, and then you have irrational numbers. Starting in the smallest subset are your natural numbers. Those are your counting numbers. So it starts with 1, 2, and 3. When you get up to your whole numbers, it's the same as your natural numbers, but 0 is added. Alright, when you get to integers, it's the same as your whole and natural numbers, except their opposites are now added, so your negative numbers are added. And then you get to the biggest subset of this part, and you have rational numbers. So as you see, rational numbers can be a fraction, a decimal, a repeating decimal. It can be negative, alright, and it can be a terminating decimal. Alright, so anything that can be turned into a fraction is a rational number. Anything that cannot be turned into a fraction is a rational number. So you have the square root of 2, pi, square root of 17, and negative square root of 11. Alright, so just as stated earlier, your natural numbers are counting numbers. The whole numbers is the natural numbers including 0. Integers are your numbers and their opposites. Rational numbers, any number that can be expressed as a over b, where b is not 0. So any number that can be a fraction. If it cannot be a fraction, then it is irrational. Okay, so irrational numbers are simply, you cannot turn it into a fraction, and these decimals do not terminate or repeat. A tale of two families. Let's take a look side by side. So rational numbers, once again, consist of terminating and repeating decimals. Any terminating or repeating decimal will convert back to a fraction, hence why it is a rational number. Terminating decimals are rational numbers in decimal form that have a finite number of digits. So they end, okay? So you have 3.75, 1.2, 4.0, and perfect squares as your examples. Repeating decimals, they repeat, but they do it continuously, so it is a pattern. So for example, you have 1.2 repeating, 5.1313, and then you have 2.356356. So the numbers that repeat are a pattern. That's how you get your repeating decimals. Rational numbers cannot be expressed as a fraction. Some examples are roots of whole numbers that are not a perfect square. We'll get into a perfect square in a minute. Pi, and then decimals that do not repeat or terminate. So it's just a bunch of different numbers after the decimal. So tuning in on that perfect square, it is a number whose positive square root is a whole number. Some examples of perfect squares are shown in the table. So you have, if you square 0, you'll get 1. If you square 1, you'll get 1. If you square 0, you'll get 0. You square 1, you'll get 1. You square 2, you'll get 4. So the square root of all of these numbers in the yellow are perfect squares. Alright? The square root of all of those numbers in the yellow are perfect squares. Alright, so let's talk it out. Number 1, simplify the square root below if possible and determine if it is a perfect square or not. So here we have the square root of 12. Now, in order to figure this out, move this over here. Alright, you would just type in Desmos, which is your online graphing calculator, the square root of 12, and then you would get 3.4641016, and it repeats. Okay, I'm sorry, it continues. Alright, so we know this is not a perfect square because we do not get a whole number as our answer. Okay. Number 2. Simplify the square root below if possible and determine if it is a square root, a perfect square or not. So we have the square root of 81. Alright, we put it in decimals, or if we just know our multiplication tables, we know that the square root of 81 is 9. So because this is a whole number, it is definitely a perfect square. Alright, so just a quick check for understanding. Patrick was confused when Miss Sutton said -8 is a rational number. He felt like it didn't make sense because earlier Miss Sutton stated all rational numbers can be expressed as a fraction. And he does not see -8 as a fraction. What could you tell Patrick to clear up his confusion? What could you tell Patrick to clear up his confusion? I'll give you a moment to think about it. Alright, so Patrick, so we're looking at this, and Patrick said that -8 does not look like a rational number because it's not a fraction. But if we remember, we can turn all whole numbers, integers, natural numbers into fractions just by simply putting this whole number or integer over 1. Alright, so -8 over 1 still can be expressed as a fraction. It just simplifies to -8, which is why we just write -8 there. Alright, so your concept summary. The real number system is comprised of all numbers that can be represented on a number line. So basically, in short, any number that you can think of is a real number. These numbers can be organized into subsets called natural numbers, which are your counting numbers, whole numbers, which are the same, including 0, integers, which are the same as whole numbers, but add your negatives and your opposites, and then your rational numbers, any number that can be a fraction, and your irrational numbers, those numbers that cannot be expressed as a fraction. Numbers can be easily placed into their appropriate subsets by recognizing their characteristics. All right. The major two components of the real number system are rational and irrational numbers.